Good morning to all. I am Priti Choudhary, working in Akgec Garg Engineering College as a assistant professor in IT department. So today I will discuss about next data structure point, that is tree. So today I discuss about the tree terminology, types of trees, height of trees. Okay, so these are the some points is covered in this session. In my previous session already I discussed about different types of data structures like array, linked list, stack and queue. Now I comes to the next data structure, that is tree. So before I start the tree, I tell you one thing, that is tree is a non-linear data structure. It means here data is stored as a randomly way, not a sequence way. Before the session, I used linear data structure, array, linked list, stack, and queue. These data structure used as a linear data structure, and data is stored in a sequence way. But now comes to the non-linear data structure. This is the part of non-linear data structure, and it means data is used as a random way. This tree and graph both are the non-linear data structure. So in this lecture we covered these topics: basic terminology in binary tree, strictly binary tree, complete binary tree, almost complete binary tree, height count of tree. So now comes to the tree terminology. Firstly, so what is tree data structure? Tree organized in a hierarchical manner. Here data in a linear data, data is stored in a sequence way, but here the data is stored hierarchy way. This is called a hierarchy. Okay, so organized data in a hierarchy manner, it is a non-linear which does not have any closed region. So comes to when we create the tree, when we inside the tree, you know the some terminology of about the tree. First one is root. What is root? Root node is the first node of any element, any tree. Okay, then we start the other branches, create the other node. So root node, start node or first element of a tree. A tree may have only one root node, always present and must, but only one root node. What is edges? Edges is just, we can say that the connecting line to another node. It is a link which connects to node. If there are n node in a tree, then it should be n minus 1 edges. Now comes to the parent node. A node is called a parent node if node has any number of branches while moving from top to bottom. According to this, now comes to the this is the diagram of a tree. Now I tell you the all terminology used in this tree. So this is the first element of the tree, called a root node. Got it? These are the last element of the, called a leaf node, and this portion is called a internal node. Leaf node have no child. Okay, last node means that node have no child is called a leaf node. According to this, H have any child? No. So it is a leaf node. Same thing, E have no had any child? No. No left child, no right child. So it is called a leaf node. Same, this also leaf node. But here the K is also leaf node. But G is not a leaf node because G have right child. This one is key. So H, the parent of D. B is the parent of D and E, and C is the parent node of F and G, called a parent node. So this is the parent of this part, and these two parent always these 4 elements, called a D. E is the child node of this, F and G is the child node of this. And same thing is, one node is a child of this node, D node, and same thing is K is the child of G node. So this is the simple terminology of a tree. And now comes to the level. Level is, first root node always lie 0 level. Next one is this part, 1 level. This one is 2 level, and this one is 3 level. So how many level in this tree? 4 level. 0, 1, 2, 3. Total 4 level are used in this tree. So you know now what is root node, what is leaf node, what is internal node, what is edges, what is node. So these are the some points and these are the some terms in the terminology of tree. Same things. Here I use the different types of leaf node, child node, root node. So this is the simple definition of these terminology terms. So first one is the child node. A node which has edge from its parent node is called a child node. In a tree, all nodes are child node except the root node. So all tree are the child node. Now comes to the second point, that is sibling child node of the same parent. Same parent node are called the sibling which each other. Now comes to the next node, leaf node. A node which does not has any child is called a leaf node. Okay, now come to the internal node. Internal node means tree terminology. Internal node means between node. These are the internal node. Okay, so internal node, this is the node which have child or node other and then leaf node. Now comes to the degree. What is degree? It is defined as a number of children a child node of a parent is called a degree. Let's suppose how many connection leaf node have no child. So degree is always 0 of leaf node. Degree of a tree is equal to the maximum degree among all the nodes. Now comes to the level of tree. So as I discussed the last slide, this different types of level. 0 level, root node always lies 0 level. Now comes to the 1, now comes to the second, this one is the third. So 0, 1, 2, 3. So these are here the 4 level. So what is the label? So it can be defined of each step in a tree. Level start from 0 and it is increment by 1 while moving from root to leaf node. Now comes to the height. Height of any node is the longest path. Okay? Height is the longest path from leaf node to नीचे से ऊपर की तरफ height. And height of the tree is longest path. What? Longest path of height is leaf node to root node. And height of leaf node is always 0. Now come to the depth. Depth of the node is defined the longest path from root to leaf node. And depth of the tree is defined the longest path from root to node in leaf node. And depth always root node is down to upward direction and root is depth is root to down direction. So according to here we can easily check the depth of so height of this node, so down to upward direction. So from here we check the height of this node H is 0, always 0. And according to this always 0. But depth is 1, 2 and 3. These are the edges of called the depth. 1, 2, 3. The depth of this H node is 3. So in this way we can easily find out the depth or height any node. Let's suppose we take the second. This one is B. B we check the height from this down to N2 is the height of 2 and depth is, so that is 1. The depth of B node is 1 and height of this node is 2. Now comes to the next terminology is path. What is path? Path can be defined as a sequence of edge from source node to destination node. It can also be defined as a sequence of node from source to node to destination node is called a path. Path means the connection from one node to another node. Now come to the subtree. Node which with the any number of child node is called a subtree. Let's suppose subtree is what? According to this is the left subtree and this is a right subtree of this tree. So a tree is called a binary tree. So comes to the first tree, that is binary tree. Binary tree means a tree is called binary tree if T has either 0 child, 1 child or 2 child. So according to this, these are the example of binary tree. So according to this, here no child, so left side and right side both, so called a binary tree. Now we check this node have left node but not a right node, but it is also one child, so called again binary tree. And now comes to the here, this is binary tree because left subtree is full and right subtree is also full, is called a also the binary tree the part. Now comes to here, only one child, it is the binary tree, or no child here of this tree is a, it is also a binary tree. It can not have a more than 2, means child have maximum value is 2 and minimum value is 0 and 1. So there the unique path from root node to every other node. So binary tree, they are the different types of binary tree is used. Firstly the fully strictly binary tree, second is perfect binary tree, third one is complete binary tree, and fourth one is almost complete binary tree. So fully strictly binary tree, it means here each node have either 0 child or 2 child. According to this, no child, and this is only 2 child. So same thing. So fully or strictly binary tree means child each node has either 2 or 0 child. Now comes to the perfect node. Perfect node means each node has either 0 or 2 child, but all leaf nodes should be at a same level. These are the leaf node are used in a same level. So this is called a perfect binary tree. So according to this, this is also perfect binary tree. But according to this, so level is different. This is also leaf node and these two also leaf node, but leaf node are not a same level. So this is not a perfect binary tree. Now comes to the next binary tree, that is complete binary tree. All level are completely filled except the possible last level. ठीक है, तो all are filled last level को छोड़ के, all last element might or might not be filled is completely. If last level is not full, then all nodes should be filled from the left. Let's suppose we take the example here. This is the simple tree. Here all nodes are filled, so this is a completely filled except this. So this is the also the example of binary tree, and this is also the example of complete binary tree, because here the last element is totally filled. According to this, fill the possible the last element, so maybe it is filled or not. Okay, and application of complete binary tree, it is used in heap data structure also. Now comes to the next types of binary tree, that is almost complete binary tree. Almost complete binary tree means all level are completely filled except the last level. Also last level must not be filled completely. If last level is not full, then all nodes should be filled from the left. It means if create the tree, then all create the tree and we use the completely filled at a last level also. So this is also the almost complete binary tree, but if create the new level, then that must be filled left to right. Now comes to the height of node, and in this way we can easily comes to the height. So if you want to check the height of each node, then you apply these things for depth, and this approach apply for this. So this is called the complete almost completely binary tree. So height of number of node you can check that in different way, and So these are the some different points I will discuss. First one is binary tree. What is binary tree? I tell you, and old tree terminology I tell you. Next one is binary tree. As I discussed, types of binary tree: fully strictly binary tree, perfect binary tree, complete binary tree, and almost completely binary tree. Types of binary tree: perfect, this. Now comes to the complete binary tree. Example of this: almost complete binary tree, also the discuss in this way, and the height and number of node in a binary tree. So thank you.